Hello my dear children, welcome back once again to our chemistry online class. So, on the last class we discussed about oxygen family. Now, another family is group 17 elements which belongs to halogen family. The groups belongs to this family are fluorine, chlorine, bromine, iodine and astatine. And they have the general electronic configuration of Ns2, Np5. Fluorine and chlorine, which is fairly abundant element, and while bromine and iodine is also less. Fluorine is insoluble fluorides. Small quantities are present in the soil, river, water plants, bones and teeth of animals. Seawater contains chlorides, bromides and iodides of sodium, potassium, magnesium and calcium, but has mainly sodium chloride solution. Look at the electronic configuration. Fluorine have an atomic number of 9 with group number 17 and periodic number 2. Chlorine with atomic number 17, periodic number 3. Electronic configuration neon 3s2, 3p5. Bromine, argon 3d10, 4s2, 4p5. Iodine, krypton 4d10, 5s2, 5p5. Astatine, xenon 4f15 and 5d10, 6s2, 6p5. Look at the oxidation state and trend in chemical properties. All the halogen have exhibiting -1 oxidation state. However, chlorine, bromine and iodine, they exhibit the oxidation state of +1, +3, +5 and +7 state. It's because the oxidation have been happened there. Coming to the reactivity of these elements, fluorine is a very strong oxidizing agent and it can oxidize other halide ions. For example, fluorine, when reacted with another halogen atom, it can reduce to fluorine minus plus X2, like that. So, it is a strong oxidizing agent. When halogen metals react with metals, it forms metallic halides. For example, magnesium when react with bromine, magnesium bromide is formed. And it can also react with non-metal also. When it reacts with hydrogen atom, it forms hydrogen halide, but the affinity for hydrogen decreases from fluorine to iodine. Okay. Next one is reactivity towards the oxygen atom. Halogen form many oxides with oxygen atom, but most of them are unstable. Fluorine form two kinds of oxides, that is OF2 and O2F2. However, only OF2 is terminally stable at 298 Kelvin. These oxides are essentially oxygen fluorides because of the high electronegativity of fluorine than oxygen. Both are strong fluorinating agent. Chlorine, bromine and iodine can form oxides with a variable oxidation state ranging from +1 to +7. And we can identify the decreasing order of stability of oxides as halogen, iodine greater than chlorine, greater than bromine. It also forms various oxides like Cl2O, ClO2, Cl2O6, Cl2O7, etc. So it is act as highly oxidizing agent. Where perchloride is act as a bleaching agent for water, pulp and textiles, and also is used as water treatment. Another bromine oxides are Br2O, BrO2, BrO3. They are very less stable halogen oxides and have low temperature at exist. Another oxides of iodines are I2O4, I2O5, I2O7, which are insoluble solids and decompose on heating. Reactivity of halogen towards other halogens. Halogen when combined among themselves to form interhalogen compounds. For example, XX-, XX3-, XX5-, etc. Where XX7, which is a high soluble, large in size halogen atom. Fluorine have some anomalous behavior like other compounds. Ionization enthalpy, electronegativity, and the electrode potential are all higher for fluorine than expected from the trend. Also, the ionic and covalent radii, melting point and boiling point, enthalpy of bond dissociation and electron gain enthalpy are quite lower than expected. The anomalous behavior of fluorine is due to its small size. High electronegativity, low fluorine-fluorine bond dissociation enthalpy, and non-availability of d orbital in valence shell. Most of the reaction of fluorine are exothermic. It also forms one oxoacid while other halogens form number of oxoacids. Hydrogen fluoride is a liquid which have a boiling point of 293 Kelvin and it can form strong hydrogen bond. Other hydrogen halides are also gases. Chlorine. Chlorine, which was a compound discovered by Scheele in 1774 by action of HCl on MnO2. In 1810, Davy established its elementary nature and suggested the name chlorine on account of its color, which means a Greek word greenish yellow. How the chlorine is prepared? It can be prepared by various methods by heating manganese dioxide with concentrated HCl to form manganese chloride plus chlorine plus H2O. It also prepared by the action of HCl on KMnO4. 2 KMnO4 plus 16 HCl giving 2 KCl plus 2 MnCl2 plus 8 H2O plus 5 Cl2. You can write any of the one reactions for the preparation. Manufacture of chlorine by industrial process is done by using two kinds of process. One is decant process and another one is electrolytic process. Decant process where hydrogen chloride gas is undergo oxygenation by the presence of atmospheric oxygen in the presence of cuprous chloride as the catalyst at 723 Kelvin. While in electrolytic process, chlorine is obtained by electrolysis of brine solution, that is sodium chloride solution, where the chlorine is liberated as anode and it is also formed as a byproduct in many chemical industries. Looking at the properties of chlorine, it is a greenish yellow gas with a pungent smell and suffocating smell. And it is very heavier than air. It can be easily liquefiable. It boils at 239 Kelvin. It is soluble in water. It can react with both the metals and non-metals to form chloride. It has a greater affinity for oxygen. Look at the uses of chlorine. It is used for bleaching food pulp. It is used in the extraction of gold and platinum, for the manufacturing of drugs, dyes and other organic compounds. It is used in sterilizing drinking water, preparation of poisonous gases such as phosgene, tear gas, mustard gas, etc. So these are the properties of halogen family. Hope you get the concept of halogens and its chemical properties, usage, etc. The related link along with the notes is attached along with this video. Go through the link and download the notes. And it is compulsory to attend the test paper without any fail. See you on the next class. Till then, take care. Bye, students.